In this segment of Tech Nation, we'll look at Fundibot on how they are accelerating science learning in Africa with a mission to at least enrich 1 million African students by 2030.
And we do this through 3 pillars. So we have Fund at School, Fund at Home, and Fund at Work. So we also have Fund Girls, which cuts across all the pillars. And when it comes to robotics, that's where we train students how to build a robot. It's a bit exciting. What we do here is that we get an idea from Fund at School. Then we sit down as a team, we brainstorm from ideation. Then we use softwares like SolidWorks, as you can see. Then we use programming.
Which languages?
C++, Python. Okay. So now once we get on the idea, so we come and brainstorm, we do ideation, we do prototyping. After doing several iterations, and we finalize that, okay, this one is okay, we send it for another department, which is the production process, where we get to use the 3D printers, as you can see, and we use the laser cutters, the CNC rotor, and the assembly room, where we have a couple of technicals.
Henry, I can see this is Letani Rover 1, and this was
a Camry.
A Camry, right? So we're gonna see how this works. And they are robots, of course. You're gonna see exactly how they look like while they're working.
With an application.
It's a phone application, don't worry.
A phone application whereby I can control it using a phone.
Okay, and this one?
So this one is in sensing mode.
Nice.
But now, if a student is actually assembling this, he's learning a lot of mechanics, electronics, programming. So if you make it move, that means the skills you have got just mere making this move. Okay. Now you know how sensors work, you know how to program, you know how to use screwdriver. Now motors move, okay, something like that.
Yeah. This is a panel.
Yes, a solar panel.
To power it while it's doing its work.
Its work in the garden. Okay. This is now the storage area and the robotic arm.
This is the robotic arm to harvest.
Yes, we try always to use the local materials we have here. And mostly if you are going to look at our tools and robots, we normally use wood and plastic. Where we are standing is a laser cutter room. So these are the 2 laser cutters. Like we have the big one and the smaller size one.
Yeah. So this is what actually it has just cut.
Yeah, this one.
What are these?
These are gears.
Okay. And these?
This is a tool. Now we're doing mass production. So after doing such a development,
this also the laser has cut from.
Yeah, the laser cuts on this.
Wow.
So this is a CNC router. Okay, we use it for mass production. So once I showed you in SolidWorks that is wooden, so we cut it using this machine. So now this is the assembly room, whereby after cutting out all the pieces, this is where we do an assembling from.
Okay. Yeah. Can I have a look? Yeah. So this is how it looks like.
That's how it looks like now.
BOAT is a short for robot, a computer program that operates as an agent for a user, other program, or to stimulate human activity. Boats are normally used to automate certain tasks, meaning they can run without specific instruction from humans.
Our major primary tool is to objective is to develop tools for schools, whereby we are assisting the national curriculum, make it like more practical other than being theoretical. So we are going to put a lot of IoT in farming, but since we are a robotics company, we started with robotics. So we want to show people that actually robots can really work on farms.
They are automated, which means they run according to instructions they receive without a human user needing to manually start them every time. Boats imitate humans and replace human behavior. So we are curious, why bots?
What is the future of Uganda with robots? Right? If you look at robots, they are machines. Okay? So if we deploy them in some areas, maybe it's like in agriculture, we expect to make agriculture smart, and making it smart, that we make it efficient, whereby I think we shall all be able to increase the yield.